All right. So matrices, not matrices. Okay, matrices, a matrix. So you're going, but gee, what is a matrix? Well, I'm going to give you the definition, and you're going to go, that doesn't sound like much. Because all a matrix is a rectangular array of numbers enclosed in brackets. Okay, so if I said to you, based on that definition, to write down a matrix, and you absolutely had no clue what a matrix was, and you already know you can't answer, what on earth is it? I lost my R. A rectangular array of numbers enclosed in brackets. Just anywhere I want. I put brackets around it. What does it mean, a rectangular array? An array is something that's in rows and columns. So it's a rectangular shaped set of numbers in rows and columns. So this is a matrix. The numbers are arranged in rows and columns, and they've got brackets around it. Okay? So you're going, lovely, I have numbers in this rectangular array. Okay. Why would I put numbers there? Okay, well, one real world example. What do you want to sell? Cookies. Okay? I know and the reason matrices have become so popular because this is a way to organize information with computers. It's very easy to program matrix operations in computers. Suppose you have Keebler cookies and, let's see, we got fudge stripes. What other Keebler cookies are there? I'm not good at my cookies. Grasshoppers. Oh, hold it. Can't be just. It doesn't have to be just Keeblers, but okay. This is 10-ounce packages, and this is the big packages. This is the 24-ounce packages. So this could be a way I keep track of my inventory. I have 2 10-ounce packages in stock. Oops, I'm out of grasshoppers or in the 10-ounce size, but I got 6 fudge in the 24-ounce size. So I can't. I would have to get rid of the negatives. How would you mean negatives? Yeah, sorry. Don't have negatives. You wouldn't have negatives if we're going to talk cookies. But it can be your inventory. How many do I have of each thing? It's a way to organize and arrange things very easily. Because the way a computer's memory works, when a computer stores data, it stores it in what's called an array. And it's like there's a little post office box, and it puts the first piece of data in the first box, and the second piece in the memory. The computer's memory is segmented off into little sections, and it simply stores each piece of data in a different section, and it keeps track of where they are by putting them in rows and columns. It's like a giant mailbox wall. That's how it works. It's really easy, then they treat that like a matrix. Which is why I never saw a matrix until I went to college, and now they show up very early in high school. So, whoops, I didn't even do that. Correct. So, that's the reason you might have a matrix. Our goal of the day is to learn how to add and subtract, but first you have to learn a couple things. A matrix has dimensions, and it is really important. The dimensions tell you when you can and cannot do things with a matrix. Okay, the dimensions are given as the number of rows by the number of columns. Okay, so how many rows does this matrix have? And which way do rows go? Rows are going across. It has 2 rows, yes. How many columns? 4. So we would call that a 2x4 matrix. 2 rows, 4 columns. Each of the little separate numbers, each individual number, is called an element. So there are 8 elements in this matrix. Right. What we want to do is learn how to add and subtract them. And I am going to blow your minds with this. This is incredibly difficult. Okay. I want to add those two matrices together. What is your gut instinct about how you might do this?
Going across.
What do you mean we go across?
Do like,
Okay, so you're saying add 3 to 8, negative 6 to 0. Top left corner to top left corner, top right corner to top right corner.
Yeah, makes sense.
The ones that are in the same location, that are in the same spot, you add them together. That's all it is.
well then.
Told you I was going to blow your mind. So I'd have 11, negative 6, negative 5. Last row?
10 and 3.
That's negative 1.
Oh, I was gonna.
And ta-da! You have a resulting matrix. Boy, puppy, that was a toughie. I will challenge your brains here a little bit in a moment.
Yeah.
Yes, you will.
All right, so suppose I said, what do you do in this situation? What if I give you 0, 7, negative 6, 3, and I say add it to 4, negative 3, 5, 2, 1, 0. How do I do that? So you're thinking I pretend like there's another column of zeros here?
Yeah.
That's what everybody always wants to do.
Is that not it?
Nope.
If the middle one goes and good or what?
Nope. Anybody else? What? If you can't, you cannot add more numbers to a matrix.
It would sound smart to me.
So if I can't add any more to it,
Just make 5 and 0 disappear.
yep. You just, well, what would you be saying the solution is then?
Can you combine the negative 3?
No solution. It's not possible. You can't do it. It has to be the same dimensions. If they aren't the same dimensions, you cannot add and subtract. However, that's only on addition and subtraction. Multiplication, there's a different rule for when it's possible or not possible. So, but we first we need to do some incredibly difficult subtraction here as well. So suppose I gave you 3 times 2, 6, negative 1, 4, minus, oh no, 8, negative 7, 9, negative 2. I'm not to multiplication yet. Division is not possible, but you can, we will eventually learn, when we come back to this in September, we'll learn you can create an inverse matrix, which is kind of the equivalent of division. We aren't going there at this point in time. All right, so what do you suppose that 3 out front means? Times by 3. And you want to do that first. So now, do I times just these first column numbers by 3? Yeah, the entire matrix times 3. So you're going to go 6, 18,
Negative 3.
12. Okay, now, here's where you have a choice. I know what my recommendation is, but you can do it either way. We can leave it as subtraction. Personally, I see people make mental mistakes if they leave it as subtraction. What would be the option? I would change it to addition and do what to these? Change all the signs. I think I see less errors that way. So I would go negative 8, positive 7.
7, 8, 9, 2.
Okay, so it's up to you. You could subtract them. You could leave it as subtraction, but you would have to then remember to subtract every number. But I think people add better and make less mistakes.
You multiply that side by three?
So, okay.
No, it's only 3 times the first one. Yep.
Okay, on the study guide thing, whenever you have it 4 by 7 by 7 by 3, so that.
So that's there, yeah. That's multiplication.
Okay, I didn't know if that was the.
Yeah, that's the multiplication.
Or not.
I might have asked you on there about, I don't remember if I asked you about,
So you didn't know if you meant like by row, like the numbers.
the two sets of dimensions, that's multiplication, that's coming in a second. So if I add these together, we're going to learn to graph on our calculators, I hope. Today, yeah. Sure it is. -2, 25, -12, 14. So you have added your matrices.
So this multiplication is possible when.
Addition and subtraction is pretty basic. Now, multiplication is not hard. You just got to make sure
So wait, but that is possible when. Because addition and subtraction is when they're the same thing.
multiplication, division, I'm kidding. Maybe we'll say it's possible. That's what I have to get. You got to see multiplication happen. It's a little weird. And how somebody figured this out, I don't really know the history of how they came up with it. Well, in this case, a lot of times, this can actually be used to, we'll have to solve equations with it. You remember solving, like back in Algebra 1, if I gave you 2x plus 3 equals 8 and x minus 4y equals 11, and you did substitution or elimination and you had to solve for x and y? Okay, we'll actually discover when we get to that section that we can solve that with a matrix equation. Probably faster than anything else, particularly if you use that calculator, you can get an answer like that if you use matrices to solve it. So somebody was playing with the idea of how can we solve equations, and they wanted to get rid of all the variables, and they started pulling the numbers off and making matrices out of them, and then the way most math happens, we want to find a way to do something, so then we start playing around with the numbers, or we invent something new and prove it to be true, and it just happens. Then we find all these real world connections that go with it later after we discover simple math. All right, multiplication. Are you thinking these dimensions aren't right?
Well, no, since you said.
Okay, well in this case, the dimensions have to be the same if you're adding and subtracting. Okay, if you're multiplying, let me explain what you multiply and then you'll understand what the dimensions tell you. When you multiply, you are multiplying the row of the first matrix you're coming across times the column of the second matrix. So, if you have 3 going across the first matrix, you have to have 3 going down the second matrix. If you don't, it's no solution. So if you look at the dimensions, this one would be a 2 by 3.
That'll be it.
A 3 by 2. It's these middle 2 numbers have to be the same. If the middle 2 dimensions are the same, it'll work. If they are not the same, it won't work. Or you can tell me if you got the number across the first matrix has to be the same number as what's going down the second matrix, however you want to explain that to me. But now the interesting part, if these 2 numbers are the same, the 2 numbers that are left over, the 2's here, that's our answer is going to be a 2 by 2. It tells you what size answer you will get. So let me, suppose I told you you were going to take a 7 by 9 times a 9 by 30. What will be the dimensions of the resulting matrix? A 7 by 30. Since these 2 are the same, the outside numbers give you the answer. 15 already? Boogers.